Greetings to you all. In this session, let's delve into the general knowledge of subgrade construction. Let's start by learning about the process of subgrade embankment. The tasks for construction preparation include ensuring the availability of manpower, materials, and machinery. Subsequently, pre-filling foundation-based treatment is carried out, followed by quality testing. Once the testing is successful, the transportation of fill materials can commence. Before transporting packing, the selection of filling materials should be made, and the filling materials need to undergo testing. Only after the testing is successful can the materials be transported to the construction site. Before transporting the fill materials to the site, a recheck of the centerline and sidelines of the construction site roads is conducted. After a successful recheck, the laying out of materials can proceed. Next, bulldozers perform rough grading, and graders carry out fine grading. During the paving process, attention should be paid to the thickness of the subgrade. If the fill material is too dry or too wet, appropriate measures such as watering or drying can be taken. After leveling, the compaction process can be carried out. Upon completion of compaction, subgrade quality testing is conducted, and records are maintained. After passing the quality test, the process is repeated for the construction of the next layer of soil. The selection of subgrade filling materials is crucial, as it directly impacts the quality of the subgrade. Therefore, let's begin by learning about the selection of filling materials. Subgrade filling materials are generally composed of soil or stone. Soil can be classified by particle size into coarse-grained soil, medium-grained soil, and fine-grained soil. The classification is based on the size of the particles, with particles larger than 60 mm considered coarse-grained soil, particles between 0.075 and 60 mm considered medium-grained soil, and particles smaller than 0.075 mm classified as fine-grained soil. The overgrained soil is further divided into boulder soil and pebble soil. Coarse-grained soil is further divided into gravelly soil and sandy soil. Fine-grained soil includes silty soil, clayey soil, and organic soil. Before transporting fill materials to the construction site, they must undergo testing. The parameters that must be tested include water content, liquid limit, particle analysis, compaction test, and CBR test. Based on the test results, the suitability of the soil for filling is determined using the criteria shown in the table. Whether the liquid limit is greater than 50% and whether the plasticity index is greater than 26. If it exceeds this value, it cannot be directly used as a filler. Whether the soil density is greater than 1.6 grams per cubic centimeter. If it is less than this value, it cannot be directly used as a filler. If the CBR value meets the specification requirements, it can be used for corresponding subgrade filling. All levels of highways have the minimum requirements for subgrade filling strength. Taking expressways and first-class highways as an example, the CBR value of upper roadbed is greater than or equal to 8%, while that of lower roadbed is greater than or equal to 5%. The CBR value of the upper embankment is greater than 4%, and that of the lower embankment is greater than or equal to 3%. The maximum particle size of filler is also specified accordingly. The minimum strength and maximum particle size of subgrade filling materials for highways at all levels shall meet the requirements in this table. In addition to testing the corresponding parameters and indicators, the technical requirements for fillers are as follows. 1. Choose locally available materials such as crushed stone, gravel, gravelly soil, medium sand, and coarse sand with good permeability, high friction coefficient, high strength, and good water stability. 2. Subsoil, subclay, and light subclay, when compacted, should have sufficient strength for use in filling embankments. However, caution is needed regarding the presence of organic matter and easily soluble salts in the soil. 3. For embankment fill materials, do not use mud, swamp soil, frozen soil, organic soil, grass-covered soil, household waste, tree roots, or soil containing corrosive substances. Salt-affected saline soil, loess, and expansive soil can be used for embankment filling after careful consideration of geological and hydrological conditions and experimentation. 4. Soils with a liquid limit greater than 50%, plasticity index greater than 26%, or moisture content exceeding the specified limit should not be used directly as embankment filling materials. If needed, appropriate technical measures meeting design requirements must be taken. It can only be used after passing the inspection. 5. Materials such as steel slag and fly ash can be used as embankment filling materials. However, industrial waste slag must undergo a harmful substance content test before use to prevent environmental pollution. 6. Crushed planting soil can be used for the surface layer of embankment slopes. 7. Permeable filling materials should be selected for immersible embankments, bridge abutments, and retaining walls. That's all for today. Thank you for listening.